Have you ever stopped and wondered how we could teach a machine to actually think? I don't mean just crunching numbers, but to really, truly reason about the world in a logical way, kind of like we do. Well, that's exactly what we're going to dive into today. We're going to build an AI that can think, one logical step at a time.
Socrates is mortal. See? Easy, right? You just did it. That little leap of logic, connecting a couple of facts to land on a brand new conclusion, that is the absolute bedrock of the machine reasoning we're going to build today. All right, so to get this whole thing started, we need to meet our main character for this explainer, the logical agent. This isn't just any AI. It's a system designed for one specific, really cool purpose, to know things about its world and to reason about those things logically. Okay, so at its core, this logical agent really has two main parts. First, you've got the knowledge base. Think of this like a huge library, just packed with every single fact and rule the agent knows to be true. And then you've got the inference engine. This is the detective. Its job is to rummage through that library, find all the clues, and figure out new things that must also be true. Every journey has to start somewhere, right? So for level 1, we're giving our agent its very first language. This is going to be the simplest, most basic form of logic it can use to make sense of the world. And this language is called propositional logic. Honestly, it's super straightforward. It just breaks the entire world down into simple statements or propositions that can only ever be one of two things, completely true or completely false. A statement like, "It is raining," is either true or it's not. There's zero in between. But, just having a big list of true or false facts, well, that's not all that useful on its own. The real magic happens when the agent can start connecting these simple ideas to build more complex rules and understanding. And to do that, it needs a special set of tools. These tools are called logical connectives, and you already use these all the time without even thinking about it. And just means both things are true. Or means at least one of them is. Not, well, that just flips the truth. But the really powerful one, the game changer, is implies. This is what lets our agent create rules, like if it is raining, then the ground is wet. This is a huge first step for our little agent.
And this brings us to the agent's first real thinking skill, an inference rule called modus ponens. It sounds fancy, but it's totally intuitive. If the agent knows the rule, if it's raining, then the ground is wet, and then we tell it, hey, guess what? It's raining. Its inference engine can automatically figure out, aha, the ground must be wet. Boom! It just created brand new knowledge out of thin air. So our agent's off to a pretty good start. It can learn facts, it can learn some basic rules, but pretty quickly, as we try to describe the messy, complicated real world, we're going to smash right into a major problem. We're about to hit a wall, and we're going to hit it hard. Just look at this sentence. All kings are persons. Seems simple enough for us, right? But how could our agent, using only these simple, true, false statements, possibly understand what this means? What would the proposition even be? You can't just say the statement, all kings are persons, is true. That doesn't actually help it reason about any individual king. And here it is, the core of the problem. Propositional logic is great for linking simple facts, but it has no idea what an object, like a king, is, or a category, like a person. It just can't get its head around general rules that apply to all of something, or maybe just some of something. So, you know what that means? We need an upgrade. All right, it is time to level up our agent's brain. To get past that logic wall, we've got to give it a much more expressive and powerful language, one that can really describe the world in all its detail. And this big upgrade is called first-order logic. Now, it doesn't throw away everything we just learned. Instead, it builds right on top of it, letting our agent represent knowledge in a way that's, well, a lot closer to how we humans actually think about things. So the first huge upgrade is that our agent can finally understand that the world is full of distinct objects. Things like John, a specific crown, or a horse. And it gets that these objects have properties, like John is a king, or the crown is blue. The second upgrade, and this one is an absolute game changer, is the introduction of quantifiers. These are special tools that let our agent make sweeping statements about entire groups of objects without having to name every single one. This is the key to letting it generalize. And there are really two main ones we need to know. The universal quantifier, that's the upside down A, basically means for all, or for every single thing.
Then there's the existential quantifier, that backwards E, which means there exists, or for at least one. With just these two symbols, our agent's ability to describe the world just explodes.
So let's circle back to that sentence that broke our last system: all kings are persons. Check out how cleanly first-order logic handles this. We can now write, for all things we'll call X, if that thing X has the property of being a king, then it also has the property of being a person. It's perfect. That abstract general idea is now captured in a precise way the machine can actually understand and use. Okay, so our agent now has a seriously powerful way to represent knowledge. It knows things, but just knowing stuff isn't enough, right? The real next step is to use that knowledge to actually do things, to make plans and achieve goals out in the world. I absolutely love this analogy from the source material. Imagine an agent's entire knowledge base, with all the things it implies, is a giant haystack. Entailment just means that a specific fact you're looking for, the needle, is definitely somewhere in that haystack. But inference? That's the agent actively digging through all that hay to actually go and find the needle. It's the process that makes knowledge useful. So how does an agent put that knowledge to work? Well, one of the most important ways is through something called planning. This is literally the process of figuring out a step-by-step sequence of actions to get to a goal. It's the agent asking itself, okay, based on everything I know, how do I get from here to there? And that whole process is, you guessed it, super logical. First, the agent has to get a clear picture of the world as it is right now. That's its current state. Then it needs a clear picture of the world it wants. That's the goal. And from there, its inference engine kicks into high gear, searching for a valid sequence of actions that can build a bridge from the state it's in to the state it wants to be in. Wow, so we've taken our agent on quite a journey, haven't we? We've basically built its mind from the ground up, from simple little facts all the way to complex reasoning, and even the ability to plan its own future. Let's just take a quick look back at how far we've come. Just think about the transformation here. We started with an agent that could only see the world in simple true-false statements. But then we leveled it up. We gave it the power to connect ideas, to really understand objects and categories, and even to reason about all or some of something. We've built an agent that can genuinely know, infer, and plan its way forward. And this entire journey, from this simplest logic to this complex web of reasoning, it forms the foundation of so much of what we call artificial intelligence. So I'll just leave you with this to chew on. As these systems get more and more complex, more and more human-like in how they represent and reason about our world, what does that mean for our future? It's a pretty big question to think about. Thanks for exploring it with me.